Okay, good afternoon all. You all are welcome to the course Computing Fundamentals. I think you can hear me. Can you hear me?
Yes, madam.
Okay, thank you. So I have uploaded your syllabus to the Moodle. Did you see that? I guess you saw that, okay? Did you read it? Okay, so this is the syllabus for Computing Fundamentals, and I think you know me. We met on Tuesday in the math class. Okay, I'm Madhusha, one of your lecturers for Computing Fundamentals. Okay, part of this course will be done by me, and also the one part will be done by Mr. Manisha. Okay, so you have lectures on every Friday from 1:15 to 4:15. So this includes all lectures, tutorial classes, and also lab sessions. Normally the lectures will be going from 1:15 to 3:15, like that. That depends, okay? And for this course, your tutor will be Miss Deepani. So if you have any doubts related with this course, you can contact me, and also you can contact Miss Deepani and also Mr. Manish. Okay. So I think you are okay with the syllabus. The main idea of this course is to get an idea, the basic idea about the computer science, the computer architecture, okay, including both the software and hardware, okay. So you do not need any previous knowledge regarding this, okay. We will be starting from the beginning. So here you can see what are the learning outcomes of this course. Okay, so from this course you will be able to describe how a program is executed in a computer, and also you will be able to design the logical circuits. You will get a basic idea about the logical circuits. So from that idea you will be able to design some logical circuits. Okay, so after that you will be learning about the operating systems and also the basic models of computations. Okay, and these are the main topics of this course. Okay, there are four main topics. In the first chapter you will learn about the Boolean logics. Okay, then after that the system architecture and the basics of operating systems, and also the finally computing models. Okay, so same as the other classes, for this class you will get the homework and also quizzes. So, and remember that also for this class you will have two in-class assignments, two in-class exams. Okay, and each from in-class exams, 25% will be added to your final exam. Okay, now here you can see from the first in-class exam, 25% will be added to your final exam, and this from the second one also 25%, and also the final exam 50% will be added to your final grade. Okay, then you can see the total will be 100. Okay, and also to get a good grade, remember that you need to work hard from the beginning. Okay, and also here you can see the references. What are the reference books? There are two books. Okay, so I think I can upload these two books to the Moodle. So I have uploaded one, and also I will upload other one to the Moodle. Okay, so you can access that. The other things are very similar to the other courses. You know that the attendance is mandatory. If there is no 70% for the attendance, you cannot sit for the final exam. So you need to attend for the lectures. Okay, so don't miss any exam. If you miss any of the exams, you have to inform me within 3 days. If there is a specific reason, If you can prove that, you will get a makeup exam for those tests. If not, you will get 0, okay? So those are the main things I need to remind regarding the syllabus. Do you have any doubts? If you do not have any doubts, so I think today we can start from the first chapter. Okay, can you see the screen? We are going to start with the first chapter. In the first chapter, we are going to learn about the digital logic. Okay, do you have any idea regarding the digital logic? Any idea? And we know that if we take digital computers and also if we take any other digital systems, they are constructed using digital circuits. Okay, so if we take any digital systems, they are constructed by using digital circuits. So main idea of this chapter is get the basic knowledge about those digital circuits. Okay, so in this chapter we are going to learn about the Boolean algebra and also the laws related with those Boolean algebra and also the theorems and the operations of Boolean algebra. Okay, then after that we will learn about the simplification of Boolean algebra, and also we will learn about the truth tables, and also finally we will learn about the logic gates and the combinational circuits. Okay, so now we are going to start with Boolean algebra. So can you tell me what's the Boolean algebra, or can you tell me what's the algebra? Just algebra. If we take just algebra, do you have any idea regarding that? You know the algebra, okay? If we take just the algebra, okay, that's O-level maths, okay? So we are working with the variables and also the operations, okay? If we take just the algebra, in that case, we are working with the variables and also the operations. So also if we take the Boolean algebra, that is also the working with the variables and also operations, okay? So, right. And, okay, do we have any idea what's the difference between the just algebra and Boolean algebra? Now we know the both are working with variables and operations, okay? And as I said earlier, we know that if we take any digital system, they are constructed, they are developed by using the digital circuits. And also if we take the digital circuits, they are designed and also analyzed with the use of mathematical discipline, and that is called the Boolean algebra. Okay, we are using Boolean algebra to design and also analyze digital circuits. Okay, so now we are going to see the difference between just the algebra and the Boolean algebra. I think you know if we take just the algebra, in that case we are working with variables. Okay, by using any letters, we can represent variables just like X, Y, A, B. Okay, by using any letter, we can define variables. And what are the operations? What are the operations? Okay, we are talking about only the algebra, not the Boolean algebra, right? So if we take just the algebra, we are working with variables, okay, and also the operations. If we take operations, the operations are addition, subtraction, and also we can take the division and multiplication. Like that, we can take many operations regarding with algebra. And also if we take these variables, remember that this variable can take any real number. Okay, this can be equal to any real number, just like this can be 1, 1.5, this can be equal to 100, 1000, 150, 100.5, like that. That can be equal to any real number. And also we can combine these variables by using any of these operations, right? We can combine these variables by using any of these operations. That is called the algebra, okay? And now let's see the difference between the Boolean algebra and the algebra, right? If we take the Boolean algebra, here you can see for the Boolean algebra, we have logical variables and also we have logical operations. Okay. Now here we have the difference. In the Boolean algebra, we have logical variables and also we have logical operations. Okay. Now let's see what's the difference between these variables and these operations. Okay. First take the variable. Now what will happen if we take any variable in the Boolean algebra? It can take only two values. Okay, it can take only two values. What are those values? Okay, here you can see there are only two values. The values are 1 and 0, right? The values are 1 and 0. And also by using this one, we represent the true value, and also by using 0, we represent the false value. Okay. For example, if we take, if x is a Boolean variable, right? If x is a Boolean variable, sorry. If x is a Boolean variable, now x can be equal to 0 or x can be equal to 1. Okay. And here you can see the difference. If we take these variables, okay, this can be equal to any real number. But now here we have the difference. The Boolean variable, it takes only two values. What are the values? 0 or 1. Okay, x can be equal to 0 or x can be equal to 1. Okay, now we are okay with Boolean variable. Okay, now let's see what are the logical operations. Okay, so let's see what are the operations related with Boolean algebra. Now here you can see we have three main operators. Okay, now here we have three main operators. What are the operators? The first one is called the AND operator, right? Here you can see the first one is called the AND operator, and the second one is called the OR operator, and the last one is called the NOT operator. Okay, now here we have three operators for the Boolean algebra. Those are called the logical operators or logical operations. Those are AND operator, OR operator, and NOT operator. Okay, so let's see how we represent these three operators. Okay, what are the symbols related to these operators? Okay, how we represent the AND operator. Here you can see the representation of AND operator. Okay, now if we have two Boolean variables, right? Now here we have two Boolean variables, A and B. Is that okay? We have two Boolean variables, A and B. Now we are performing the operator AND to these two Boolean variables. Okay, we consider these two are inputs for the AND operator. Now by using this dot here we represent the AND operator, okay? Also, this one is equal to just A and B, okay? Without using this dot, also we can represent this AND operator. The both are correct, okay? So that is the way we represent the AND operator. And the next one is the O operator, okay? The next one is the O operator. So now the symbol for the O operator is equal to the plus sign, just the plus sign, okay? If we take the AND operator, we can consider it as the multiplication between A and B, right? Now, if we take the O operator, we can consider that as the addition of the variables A and B, right? We can consider that as the addition, right? Now, what's the final one? That is called the NOT operator, not A, okay? So, by using this symbol, we represent the NOT operator, okay? That is called the A bar, okay? In some cases, you can see in some books, we represent the NOT operator by using this notation. The both are okay, right? So in this class, normally we are using this notation for the NOT operator, okay? Now, okay, any doubts so far? Okay, now let's see how we apply these operators for the Boolean variables, okay? So we know that, now we know that if we take any Boolean variable, those variables can take only two values. What are the values? What are the values? Can you answer? If we take any Boolean variable, there are two values. You need to answer, okay? If not, I cannot see whether you can understand or not, okay? Okay, now in the chat, I have answers. Okay, good. 0 and 1, right? So after applying those Boolean variables to these operations, let's see what will happen. Okay, now the first one is the AND operation, right? This one yields true, which implies the answer is equal to 1, right? After applying this operation, the answer is equal to 1. That happens only when both of its operands, that means the inputs A and B, are true. Okay. Now here I'm going to take the logical multiplication of A and B. If this one is equal to 1, okay, if this multiplication is equal to 1, that happens only when both inputs are equal to 1, right? Remember that that happens only when A is equal to 1 and B is equal to 1, okay? Now, if we take the second operation, the operation, okay, now tell me how we get true value after applying operation for two inputs A and B. Now here we have also the same variables A and B. Now the operation O, right. Now the answer is equal to 1, and remember that this happens either or both of its operands are true, okay? So remember that if these two are equal to 1, what's the answer? This yields true if either or both of its operands are true, right? Now I'm going to take both are equal to 1. Now what's the answer? No, this is Boolean algebra, okay? Not just the algebra, okay? this not the just algebra, this is Boolean algebra. Always remember that the answers cannot be equal to other values except 0 and 1. Okay, we are working with only zeros and ones, so answer is not equal to 2. Okay, so remember that if when a is equal to 1 and also the b is equal to 1, now here we will get the true value. The answer is equal to 1. Okay, now what will happen? Now a is equal to 0, b is equal to 1. We will get 1, right? When a is equal to 1, now b is equal to 0. Okay, again 1. Good. And finally, now a is equal to 0, b is equal to 0. Now the answer is equal to 0. Here you can see if at least one input, one variable is equal to 1, right? The answer becomes 1. And the other case, the answer is equal to 0. That implies that all inputs or all variables are equal to 0. Okay. And the last one, the not operator. What will happen if we get the not operation? That inverts the value, right? That inverts the value. That means if we take now a is equal to 1, right? Now a is equal to 1. I'm going to apply the not operation for this variable. Now what will happen to this one? After applying not operation to a, now here we find the value of a bar. Now the value of a bar is equal to 0. Okay, good. Now if we take a is equal to 1, now I'm going to take a bar, right? Now what will happen to the a bar? Always we take the opposite value, right? Now in this case, I'm going to take now a is equal to 0, okay? Because the previous case a is equal to 1. So now I'm going to take a is equal to 0. When a is equal to 0, a bar becomes 1. Okay, now those are the main 3 operations related with Boolean algebra. Okay, so now here you can see if we combine these 3 operations and also these variables, okay, these variables imply those take only 2 values, 0 and 1. If we combine 0 and 1 with these 3 operations, in that case here we have Boolean algebra, right? If we combine those operations and the variables, now here we have Boolean algebra. So we can consider this as a Boolean expression, okay? Now here we have how many variables? You can see how many variables. Here we have 3 variables, A, B, and C. A can be equal to 0 and 1, and also B can be equal to 0 and 1. C can be equal to 0 and 1. And also these 3 variables are combined with 3 operations, right? Here you can see, okay, all these cases here you can see the AND operation, the logical multiplication, and also here you can see the O operation, okay, the logical addition, and also here you can see the NOT operation, that is called the logical complementation. Okay, if we take the NOT operation, we can consider that as the logical complementation. Okay, any doubts so far? Okay, can we take 2 variables for NOT operation? No, we cannot. Okay, later you will see. If we take the AND operation and O operation, for those 2 operations, we can apply 2 variables or more than 2 variables. Okay, if we take AND operation and also the OR operation, for those two operations, we can input 2 or more inputs, not less than 2, okay? There should be at least 2 inputs, and also we can apply more than 2 inputs. But remember that if we take the NOT operation, we can apply only one input, okay? Like this, we can apply only one input to the NOT operation, okay? So later you will see, when we discuss about the logic gates, you will see how we apply those inputs, okay? So remember that here you can remember the meaning of the 3 operations: AND operation, OR operation, and NOT operation, okay? So any doubts so far? Are you okay with that? Okay, now here we are going to see the truth table for the NOT operation. Okay. Now, this is the way we represent the truth table related to each operation. So here we represent, okay, now here you can see for the NOT operation, we take only one variable that is equal to A, and this is the input. And also in the truth table, we are going to represent also the output of that input related to the operation, okay? In that case, here we have the NOT operation, okay? Can you complete this table? This is very simple, okay? Can you complete this one? So remember that when we design a truth table, always we need to represent all possible input combinations, okay? We need to represent all possible input combinations. So here you can see we have only one variable, and also we know that A takes 2 values. There are 2 possible inputs. A is equal to 0 and A is equal to 1. So here we need to represent all input combinations. Okay. So how we complete this table? When the input is equal to 0, now after applying the NOT operation, here you can see the output becomes 1, right? The output becomes 1. And also when the input is equal to 1, now you know the output is equal to 0. Okay. Now this is the truth table related to the NOT operation. Okay. Now, okay, I'll give you a few seconds. Now, can you can you implement the truth table related to the AND operation and also the OR operation? Okay, just try to develop the truth table for the AND operation and the OR operation. Can you do that? I'll give you a few seconds, okay? Consider only 2 inputs, okay? You can take 2 inputs A and B. And now we know when we draw the truth tables, we need to represent all the input combinations, okay? We need to represent all possible input combinations. So how many input combinations if we have 2 inputs, okay? If we have 2 inputs, how many input combinations we can represent? If we have 1 input, there are 2 possible inputs, 0 and 1. Now you need to decide how many input combinations we have if we are considering 2 inputs A and B. How many input combinations? What are the possible values for A and B? Can you tell me how many possible inputs? Okay, good. I have one answer. There are 4 combinations. Okay, good. Okay, now how we define those 4 input combinations? Okay, now for the AND operation, we have 2 inputs, right? We have 2 inputs A and B. The first input combination is 0, 0. The second one, 0, 1. And the next one, 1, 0. The last one, 1, 1. Okay. Here, A is equal to 0. And also here, B is equal to 0. And the next case, here you can see A is also 0. We change B into 1. Right. And the next one, we change A into 1. And also B into 0. Then finally, both values are equal to 1. Okay. And remember that when we design a truth table, okay, okay, right, when you design a truth table for 2 inputs, now here we have 2 inputs. I'm going to take A and B. Remember that if we have only one input, right? Now here we have one input. There are only there are 2 input combinations. What are the 2 input combinations? 0 and 1. That happens like this, okay? We take 2 to the power 1. Now here you can see if we have one input, we take 2 to the power 1. From here you can see we have 2 possible input combinations here, okay? Now, what will happen if we have 2 inputs? Now here we have 2 inputs. And also for this case, we take 2 to the power, the number of inputs. Okay, now here we take 2 to the power number of inputs. That will be equal to the number of input combinations. And here we get, now it's equal to 4. Okay, you can apply this method to find the number of input combinations. Now tell me what will happen if we have 3 inputs. Okay, now here we have only one input, right? We need to find the number of possible combinations. To find the number of possible combinations, always we take 2 to the power the number of inputs here. Okay, we take 2 to the power number of inputs. So from that we can identify here we have 2 possible input combinations, and also here if we have 2 inputs, we take 2 to the power the number of inputs 2. Now in that case we have 4 possible input combinations. And also remember that if we have 3 inputs, we take 2 to the power 3 number of inputs. Now in this case we have 8 input combinations. Okay, like that you can repeat this one. If we have 4 inputs, now we have to find 16 input combinations. Okay, so that is the way we find the number of possible inputs. Okay, now we are working with 2 inputs. Okay, currently we are working with 2 inputs. Now A and B. Okay, And when we define the possible input combinations, remember that now here we have two inputs, and also now we know that we have to define four possible combinations. To represent all those combinations, we can complete this table like this. Start with this one, right? The last input, right? Okay, I'm going to start with 0. There are several methods, okay? This is only one. You can use any method, but this one is easy, right? So we are starting from 0, and next we take, now b is equal to 1, right? Again, we take 0, and the next one is equal to 1. Okay, we have 4. So we write those 4 for the B, 0, 1, 0, 1. Okay, and now how we complete the next input? Okay, we start from 0 because here we started from 0. Because of that, also for this case, we start from 0. Now in this case, we write 2 zeros. Okay, in this case, we write 2 zeros. And can you guess what will happen to other two values? Now here we have 2 zeros, and now here we have 2 ones. That is the way, that is a simple way to complete the truth tables. Okay, 0, 1, 0, 1. Here we have 0, 0, 1, 1. Okay, now here you can see we have 4 possible input combinations: 0, 0, 0, 1, 1, 0, 1, 1. Okay, so we can do the same thing if we have 3 and also the 4 variables. Okay, so can you find? Okay, now here we have 3 inputs. Okay, if we have 2 inputs, we have 4 combinations. Now what will happen if we have 3 inputs? First of all, you need to identify how many input combinations. Okay, first of all, we need to identify how many input combinations. Okay, now you know that if we have 3 inputs, the input combinations will be equal to 2 to the power 3. Now here we have 8 combinations. Okay, so here we need to represent the 8 combinations. Now how we represent that? We do the same thing. Okay, we do the same thing. We start from the last input, C, 0, 1, 0, 1, 0, 1. We have 8. Okay, now here we wrote 6, 1, 2, 3, 4, 5, 6, 0, 1. Am I correct? Okay, we completed one column. Okay, the one input, C. Now how we complete the next input? We do the same thing. We start from 0. Now we repeat that. 2 zeros. Okay, here we have 1 0. Here we have 2 zeros. Next, same pattern. Okay, 0 0, 1 1, 0 0, 1 1. Okay, now we completed the next column, B. Now again here we have one more input. Now tell me how we complete that. To get the all possible combinations, to get the all possible values for A, B, C, how we complete now A? Here we have only 1 0. Here we have 2 zeros. Can you guess if we take A? Now here we write 4 zeros. Okay. 1, 2, 4. That is very similar to the 2 to the power values. Okay. Here we have 2 to the power, listen. 2 to the power 1, right? Only 1 0. 2 to the power 2. I made a mistake, okay. Am I correct now? Okay, always we take the 2 to the power values. Remember that we start from 1, 0, right? So that happens when 2 to the power 0. The next becomes 2 to the power 1. We have 2 zeros. And the next one, 2 to the power 2. In that case, we have 4 zeros, okay? So can you guess what will happen to the other 4 values? If we have 4 zeros, the next we need to have 4 ones. Okay, so that is the way we find the possible input combinations if we have 3 inputs like this. Okay, so here you can see there are 8 input combinations. So if you follow this pattern easily, you can complete the truth table. Okay, if you want, you can use any other method to complete this table. I think this one is simple way. Okay, start from the last input, we change 0 1 0 1 0 1 like that. Then after that we have 2 zeros 2 ones, 2 zeros 2 ones. Then we have 4 zeros and 4 ones. Okay, we do the same thing even if we have 4 or 5 or 6 like that variables. If we have 4 variables, the only difference is for the last case. Okay, for if we have, you can try this one later. Okay, I'm not going to complete this table. If we have 4 inputs, first we find how many input combinations. 16 input combinations. Okay, so you need to complete the table by using 16 input combinations. Just take the inputs A, B, C, D like that. Okay, you need to find 16. We do the same thing. We complete the column D, 0, 1, 0, 1 like that. Then after that, the next one, 2 zeros, 2 ones, 2 zeros, 2 ones. The next, 4 zeros, 4 ones. Then finally, you can guess, you have to write 8 zeros and 8 ones. Okay, after that, you will get a complete table for the inputs when we have 4 inputs. Okay, any doubts so far? Are you okay with that? Any doubts? If it's not clear, you can understand that later. Okay, when we discuss about more problems, you will get a better idea. Okay. Okay, now we were discussing about the AND operation. Okay, now here we have 2 inputs and 4 possible combinations, and we need to find the outputs related to all 4 possible combinations. Okay, now we know how the AND operation works. Okay, so we have AND operation and 2 inputs. When A is equal to 0, B is equal to 0, what will happen to the output? What will happen to the output? You can think this one like the multiplication. Okay, 0 and 0, the output is equal to 0, right? 0 and 1, the logical multiplication, the output will be equal to 0. 1 and 0, again the output is equal to 0. And finally 1 and 1, the output is equal to 1. Okay, and remember that, okay, if we take an operation, if at least one input is equal to 0, the output is equal to 0. Okay, if at least one input is equal to 0 like this, you can see the output is equal to 0. And if all the inputs are equal to 1 like this, that is the only way we can get the true value for the AND operation. We need to apply the all true values. Okay, the all inputs are equal to 1, so the output becomes 1. Okay, now The next one, okay, now you can complete this table. It's very easy. We can consider this one as the addition. Here we have the logical addition because we take only two values, 0 and 1. Okay, we are working with two values, 0 and 1. That is why we call it as the logical addition. What will happen to the first case? Okay, I'll give you a few seconds. You can think about that. Okay, am I too fast? Okay. Okay, just take few seconds and complete this table. And if you can remember when we discussed about the operation, we said that the output becomes 1 if at least one input is equal to 1. Okay, if at least one input is equal to 1, we can get the output is equal to 1 or true. And also here you can see the both inputs are equal to 0. In the first case, both inputs are equal to 0. So if we take the addition of those two inputs, we will get the 0. Okay. And the next case, now A is equal to 0. We have two inputs, A is equal to 0, B is equal to 1. If we take the addition, right? If we take the addition, now the output is equal to 1. And the next two inputs, 1 and 0, right? 1 is equal to 1. Okay, now. Muted yourself. Okay.
Sikap pembalan lo.
Okay, so the next one, 1 and 0, right? If we have 1 and 0 as inputs, so here you can see the output again is equal to 1. Then finally, we have two inputs, 1 and 1. So remember that output is not equal to 2, right? We are working with only 1 and 0. Also in this case, the output is equal to 1, right? Here you can see we can get the output is equal to 0 only when all inputs are equal to 0. And if at least one input is equal to 1, here you can see we can get the output is equal to 1. Okay, that is the way the operation or work. Okay, so this is the complete truth table for the operation. Okay, any doubts so far? Are you okay with 3 operations? Okay, now we discussed with 3 operations, not operation, AND operation and operation. Okay. And here you can see if we have more than 2 inputs, okay, if we have more than 2 inputs, okay, so I guess you can remember for those cases, we can take only 2 operations, AND operation and operation. Okay, we cannot consider the NOT operation. Okay, if we take NOT operation, we can give only one input for the NOT operation. But if we take AND and OR operation, we can apply 2 or more inputs. Okay. So what will happen if we have more than 2 inputs for the AND operation? Okay, which implies that if we have the inputs A, B, C, D like that, we take the multiplication of all those inputs and we consider only the output. Okay, we consider only the output equals 1. We can get output equals 1. For this case, all of the set, which implies all inputs are equal to 1, right? If we take the input set the inputs A, B, C, D like that. If all inputs are equal to 1, we can get the output is equal to 1. Okay, now you can say that if at least one of these inputs is equal to 0, what will happen? What will happen to the output if at least one input is equal to 0? What will happen to the output? The output becomes 0. Okay, if at least one input is equal to one thing like that. Now A is equal to 0, and if we take B, C, D like that, all variables are equal to 1. But after taking the multiplication of all those inputs, you can see the output becomes 0. Okay, if at least one input is equal to 0, then remember that the output is equal to 0. And the next case, we take the operation. Now here we have more than 2 inputs. Now this is the expression for the operation. We take the addition of all inputs. Now how we get the output equals 1? For the operation, how we get the output equals 1? Now here remember that if at least one input is equal to 1, if at least one input is equal to 1, we can get output equals 1. Okay, any of the set, the input A, B, C, D like that are 1, right? Then we can get the output is equal to 1. Okay, we can get if A is okay. Now here we take, now A is equal to 0, B is equal to 1, C is equal to 1. What will happen to the output? The output is equal to 1, right? A is equal to 0, B is equal to 0, C is equal to 1. Again, the output is equal to 1. Okay. A is equal to 1, B is equal to 1, C is equal to 0. The output is equal to 1, like that. We take the logical addition. If at least one input is equal to 1, then remember that the output becomes 1, right? Now, can you tell me how we get the output 0? For the operation, and we have more than 2 inputs. I need the output 0. How we get that? I need to get the output 0 from the operation, and we have more than 2 inputs. Now we know how we get 1. If at least one is equal to, one input is equal to 1, we have the output 1. Okay. Okay, let's see what are the answers. Okay, good. If we need the output 0, all the inputs should be equal to 0. Okay, that is only one way. If all inputs are equal to 0, we can get the output equals 0. Okay, so okay, after that, now I guess you are okay with 3 operations. Okay. Now we are okay with 3 operations. And after that, we are going to see what are the theorems, laws related with this Boolean algebra. Okay, we are going to develop the basic identities related to this Boolean algebra. When you simplify the Boolean expression, okay, when we develop the logic circuits, we need to develop the Boolean expression related to that logical circuit. Okay, first we have to construct the Boolean expression. Then after that we need to simplify that. Okay, when we simplify Boolean expressions, you need to remember these basic identities. Okay, so now we are going to develop these basic identities related to the Boolean algebra. Okay, now I'll give you a few minutes. Okay, I think now you have a note. Okay, so you can note down this table and complete this table. Okay, I'll give you a few minutes. You can do it by yourself and tell me what are the answers. I also don't know what are the answers, okay? Now you need to tell me what will happen if we take these operations. Now here we have only one input, okay? We are working with one input. If you have any doubts, you can ask me, okay? Done. Okay, you can take your time, okay? for these two rows, you will get only ones and zeros, okay? If you complete these two rows, you will have only ones and zero. But starting from here, for the last row, try to get a unique answer for these operations, okay? For these operations, in the last row, try to get a unique answer. It can be A, it can be A bar, it can be 1, or it can be 0, okay? Only for the last row, and for the other two rows, you will get only ones and zeros. Okay, in the last row, try to write these operations by using only one variable, just like by using A, by using A bar, or by using 0 or 1, okay? You need to write A plus 0 here. You need to write, oh, come on. You need to write A plus 0 by using only one value, okay? What will happen if we add 0 to A? Did you see the answers? Don't cheat, okay? How many of you completed the table? No one? You all need to try this, okay? Now I guess you have an idea about the answers. Done? Do you need more time? I cannot see you, so answer me, okay? Shall we complete the table? Okay, good. Okay, now what will happen to the first column, first empty column? Now here we have only one input, okay? Now here we have only one input. The input is equal to A, and we know that if we have only one input, we have two input combinations, two possible inputs, 0 and 1, okay? We start from here. And here we find the value of A bar, the complement of A. When A is equal to 0, we know that A bar is equal to 1. When A is equal to 1, now A bar is equal to 0. Okay, that is the values for A bar. Now in the next column, we need to find A plus 0, right? We need to find A plus 0. To get that answer, we can consider the first column, right? Here we have A, so here we can consider the first column A, right? We need to add 0 to those two values, okay? Now here we have 0. What will happen when A is equal to 0 here? If we take this, if we take this one, right? If we take this value, now here you can see A is equal to 0. We need to find 0 plus 0. So that's equal to 0, right? And in the next case, right? In the next case, now what will happen to the value of A? Now in this case, you can see A is equal to 1. We need to find 1 plus 0. Here we have 0 plus 0. Here we have 1 plus 0. Now the answer is equal to 1. Right? Now, in the last row, we need to rewrite this operation by using a unique value. Okay, by using a unique value. Here you can see we got the same answer as A, right? After adding 0 to A, we got the same answer as A. If we compare these two columns, you can see these two columns are equal. Here we have 0, here we have 0. Here we have 1. Come on. Here we have 1. Okay. Now here you can see if we add 0 to the variable A, the answer is equal to A, right? The answer is also equal to A. The final answer depends on the value of A. When you can see when A is equal to 0, the final answer is equal to 0. And when A is equal to 1, the final answer is equal to 1. Okay, whatever the value of A, if we add 0 to that value, the final answer is equal to the same value A, right? And the next one. Okay, next we need to find A plus 1, right? We do the same thing, right? In the first case, here we have A, right? Because of here we have A, again we consider the all possible values of A. Here A is equal to 0, 0 plus 1. And in the next case, now A is equal to 1. We need to add 1 to that. Again, the final answer is equal to 1. Okay. Now in this case, what will happen to the last row? You can see whatever the value of A, when after adding 1 to that value, the final answer becomes 1. Whatever the value of A, you can see the final answer is equal to 1. So here we can write if we add 1 to A, if we add 1 to A, the final answer is equal to 1, right? If we add 1 to A, the final answer is always equal to 1, okay? This is an important result. You need to remember whatever the value of A, if we add 1 to that variable, the final answer is equal to 1, okay? Remember that if we have also the two variables like this, can you guess what will happen to the final answer? Can you guess? This one is very similar to the previous one, okay? First, we can take the summation of A and B, okay? After taking the summation of A and B, we know that we can have only two values, okay? We can have only two values, 0 and 1. Similar to this case, after taking, again, we can consider A plus B is equal to C, right? After adding A and B, there are two possible values, 0 and 1. We can represent that by using another variable C. Okay, that becomes to the same expression. So you can see the final answer is equal to 1. Remember that we can have many number of inputs here like this. Many number of inputs, okay. Many number of inputs like this. If we add 1 to those values, the final answer is equal to 1. Okay, this is a very important result. You need to remember how many variables, okay? It doesn't matter if we have so many variables here. We can have like this, okay? We can have like this. We know that after taking A and B, again, we will get 1 or 0. After adding 1, the final answer becomes 1. Is that okay? Are you okay with that? Whatever the variables we have, after adding 1 to those variables, the final answer is equal to 1. Okay, very important result, okay? You will need that when you simplify the Boolean expression. The large ones, you will need that, okay? The next one is very easy. We multiply A by 0. When A is equal to 0, that becomes 0. When A is equal to 1, that's equal to 0, okay? So if we multiply any variable by 0, so the final answer becomes 0, right? And next one, that one is also a simple one. A times 1, 0 times 1, 0. When A is equal to 1, 1 times 1. Now, what's the final answer? If we take A times 1, you can see here we get again 0 and 1. That is where similar to our first column, the values of A. So we can write, if we multiply any variable by 1, A can be any expression, okay? So here we have A, like this, A can be any expression, okay? Like this, A can be any expression. If we multiply it by 1, the final answer becomes A, right? Okay, next one. A plus A, 0 plus 0, it's equal to 0. 0 plus 1 plus 0. Okay, can you see the answer? Again, that's equal to A. Okay, if we add A and A, the same variable, okay, the final answer again is equal to A. Am I correct? Did you get the same answer? You can check your answers, okay? Please correct me if I do something wrong. Did you get these answers? Are you okay with this? Up to now, are you okay? Okay, good. If you are not okay with this, please let me know, okay? Please tell me if you are not okay with this. because you will need these things when we discuss about the logic circuits. Okay, good. The next one, you will get the same answer. Okay, for the next one you will get the same answer. We multiply a by a, you will get the same answer. Come on, 1 plus 1, 1 times 1, again it's equal to 1, 0, 1, equal to the values of a. So we can write, if we multiply a by a, the final answer is equal to a. Okay, next one. Now a is equal to 0. Now here we have a bar, the complement of a. Here we found a bar, so we can consider these two columns. Okay, 0 plus 1, it's equal to 1. And next one, now a is equal to 1 and a bar is equal to 0. Again, the answer is equal to 1. Now what will happen? Another important result, if we take a plus a bar, remember that the answer is equal to 1. Okay, if we add a and a bar, always the answer is equal to 1. And next one, 0 times 1, 0. 1 times 0, it's equal to again 0. If we take a times a bar, if we multiply a and its complement, the final result is always equal to 0. Okay, the last column, we take the double complement of a. Okay, here we have a bar, right? Here we have a bar. Again, we take the complement of that complement. Okay, a double bar. Okay, now a bar is equal to 1, right? So here we take again the complement of that. What will happen? That's equal to 0. Here we have the complement of a. A bar is equal to 0, right? We take the complement of that 0. You will get 1. What will happen? If we take the double complement or if we take the double bar of any variable, the final answer is equal to the same variable. Okay, the final answer is equal to the same value. So you will get a for this one. Okay, now did you get the same answers for this table? Did you get the same table? Any problems, any questions? Are you okay with this? I hope you got the same table, okay? If you didn't get, you can try that later, right? You can complete again this one by yourself later if you didn't get these answers, okay? This is very simple. We are working with only ones and zeros. If you can remember, the complement of 0 is equal to 1, the complement of 1 is equal to 0, and also when we add two variables, the 1 and 0, and 0 and 0, 0 and 1, like that. If at least one input is equal to 1 for the addition, the output is equal to 1, right? And also for multiplication, if at least one input is equal to 0, the output is equal to 0. And if all inputs are equal to 1, we can get output equal to 1, okay? Only very simple things you need to remember. So if you can remember those things, you can easily get answers, okay? Don't worry if you are not okay with these things. When you practice more, you will get better idea, okay? This is only the first days. Sometimes you are not understanding these things, but you have to practice more. You have to do these things by yourself again. You will get a good idea after that, okay? If you have any doubts, you can send me an email or you can contact Miss Deepani. So if you have any doubts, okay, so we will help you. Now here I summarized our table by using our result, okay. Now I guess you are okay with these things. I just summarized the same table here. A plus 0 is equal to A. We got that. If we add 1 to any expression, remember that this is very important, okay? If we add 1 to any expression, the answer is equal to 1, right? If we multiply anyone by 0, the answer is equal to 0. A times 1, that's very similar to the regular multiplication. A times 1, it's equal to A. A plus A, that is equal to just A. This is also important one. A times A, that is equal to A. A plus A bar, this is also important one, right? A plus A bar. If we add complement to any expression, any variable, the answer becomes 1, okay? A times A bar, it's equal to 0, right? It's equal to 0. And finally, if we take the double complement of any variable, any value, the final answer is equal to the same value, okay? When you simplify Boolean expressions, you can apply these identities to get a better result, okay? To get a simplified expression, we can apply these identities, okay? Except these identities, also here we have some laws and theorems related to the Boolean algebra, right? The next one is called the commutative law. Okay, the next one is called the commutative law. This is a very basic thing, right? If we take A plus B or B plus A, we can switch two variables, you will get the same answer, okay? That is applicable also for the multiplication. If we multiply A and B or B and A, you will get the same answer, okay? That is called the commutative law. And the next one, that is called the associative law, right? That is called the associative law. And here we have three inputs, A, B, and C. Now we are going to take the summation of three inputs, right? Now here we have the summation of three inputs. To get the final answer, first we can take the summation of A and B, right? You know that after taking A and B, we will get 1 or 0. Then after that, we can add C to that 1 or 0, okay? So if not, here we have A. First we can find B plus C, okay? First we can find the summation of B and C, and after finding the summation of B and C also we will get 1 or 0. Then after that we can add A to those values, okay? After that we can add A to those values. To get the summation of A, B and C, you can apply this way or you can apply this way. Whatever the method, you will get the same answer, okay? That implies first you can get A plus B, or first you can get B plus C, okay? You will get the same answer, okay? That is also true for multiplication. That is also true for multiplication. We are going to multiply three inputs, A, B, and C. First, you can take the multiplication of A and B. Then you can multiply that answer by C. Okay, that is one way. If not, first you can take the multiplication of B and C. Okay, if that's easy, you can take the multiplication of B and C. As the result, you will get also 1 or 0. Then finally, you can multiply that by A. Okay, whatever the method, you will get the same answer. And the next one, that is called the distributive law. The first one is very easy, right? The first one is easy. Here we have A times B plus C, okay? The logical multiplication. We have the summation B and C. After that, we need to multiply that answer by A. Okay, remember that here we have the brackets, which implies first we need to find the value of B plus C, right? First we need to find the value of B plus C. After that, we can multiply that answer by A. And if not, right, if not, we can remove these brackets, okay? We can simplify this one by removing these brackets. How we remove these brackets? We need to multiply both values by A. A times B, A times C. Okay. Also by finding A and B, and also after finding A and C, we can add these two values. Okay. Also you can use this method to find the same answer. Whatever the method you use, you will get the same answer. Okay. So that is the first part of the distributive law. And here the next one is another important relationship, right? This one is another important relationship. Now here we have A plus BC, right? If we have A plus BC, right, we can simplify this one as A plus B times A plus C. Now here we have A plus BC. We can change this one into a multiplication, right? We converted that into a multiplication. Here we have two factors. The first factor, here we have A times B, and the next one, here we have A and C, okay? In the both cases, we have A, okay? Here we have A, so both cases, the first term is equal to A, and we split this BC into two factors like this. In the first case, we have B, and the next case, we have C, okay? So you can remember that if we have A plus BC, we can split that into two factors, A plus B and A plus C, okay? You need to remember that. Okay, so the last one, the next one, also this is another important result, which is called the De Morgan's law. Another important result, which is called the De Morgan's law. And in the De Morgan's law, in the first case, you can see here we have the complement of A plus B, right? Here we have the complement of A plus B. Okay, we have the complement for A plus B. We can convert this one into I guess I made a mistake here. Okay. Can you guess that? I made a mistake. Okay. What's the problem here? We are going to split this A and B, right, by using the complement. Remember that in the De Morgan's law, this one becomes multiplication, okay? When we convert that into a different expression, right? Here we have the complement of A plus B. So we get the complement of A and the complement of B. In this case, we change our operation into multiplication. Okay. Here I made the mistake. Okay. And also the next case, I did the same mistake. Okay. Now you can correct that. When we split our operation into two variables, we change the operation. Okay. We have to change the operation. What will happen to the next one? Can you guess? In the previous case, we had the operation, the summation. Then after splitting that into two variables, A bar, B bar, we change that into multiplication. Here we have to do the same thing. When we split that like this, we need to change multiplication into addition. Sorry about that, okay? Here we have the multiplication of A and B. After taking the complement, we can split this one into the summation like this. That becomes A bar plus B bar. Am I correct? Okay. That's a mistake, okay? Remember that here we change the summation into multiplication, and also here we change the multiplication into a summation. Okay, any doubts so far? This is very important, okay? So don't do that mistake like me, okay? When you simplify expressions, don't do that mistake, okay? You need to correct that like this, okay? Okay, now after that, any doubts so far? If you do not have any doubts, we can continue. Okay. So, okay, the next topic is the perfect induction. Right. Now we are working with Boolean expressions. So, and here you can see here we have three equations. Right. Now here we have three equations. Okay, please explain last one once. Okay, so the last one is the De Morgan's law. Last one is the De Morgan's law. If we have the complement of A plus B, right? So here we have the complement for this summation. So we can convert that into a multiplication like this by using the De Morgan's law. So in this case, here we separately write A bar and B bar. We change the summation into multiplication. And if we have the complement of A and B, now here we have the multiplication. So we do the same thing here. We can rewrite that by using the summation. So that becomes A bar plus B bar, right? When we change plus, right, by using this complement, that becomes a multiplication. So here we separately write the complement of A and B, right? And here we have the complement of A times B. So here we can write it by using the summation addition, and we separately write the complement of those two variables, okay? Later we will discuss more problems related to the De Morgan's law. If you do not get the better idea, so you will learn that later, okay? We can learn that later if you do not have better idea regarding this law, okay? So are you okay with this? Okay, the next one is the perfect induction. Now here you can see we have three equations. The perfect induction means we are going to prove whether these equations are true or not. Okay, we need to prove that these equations are true, right? In this case, you can see here we have three equations. By using perfect induction, we are going to see whether these equations are true or not, right? And also for these three cases, you will get these three equations are true, okay? So we are going to describe the validity of these Boolean expressions, okay? We are going to see the validation of these Boolean expressions, okay? So let's start from the first one, right? Let's start from the first one. Here we have A plus AB is equal to A, right? Now we are going to show that this equation is true, right? So the perfect induction means we need to show this equation is true for all possible input combinations, okay? That is the main idea of the perfect induction. We need to show that this equation is true for all possible combinations of A and B, because here we have two inputs. We know that if we have two inputs, there are four possible input combinations. For all those possible input combinations, we need to show that this equation is true. Okay, there are several methods to show that, right? We are going to take one method. The one method is to show this, prove this by using truth tables, okay? The first one is we are going to show this by using truth tables, using a truth table. So how we do that? Okay, now here we have A plus AB, and the other side we have A. We need to show that A plus AB is equal to A, which implies we need to show that our left hand side is equal to our right hand side. So in the truth table, we need to make the right hand side, and also we need to make the left hand side. And because of here we have two input variables, so A and B, we complete the table by using two inputs. Okay, if we have two inputs, we know that we can write for possible input combination. Now you know how we write that, okay? We have four possible input combinations. So we can write all four possible combinations for A and B. Now here we need to make left hand side and the right hand side. If we take any equation, this one is called the LHS, that is equal to the left hand side, and the other side is called the RHS, that is the right hand side. Then finally we need to show that the left hand side is equal to the right hand side. So we can see our equation is true if the left hand side is equal to right hand side. So we can show that our equation is true, okay? So now here we have A and B. So because of the other side in the right hand side, we have only A. Because of we have only A, we can consider now this column is equal to RHS. Now we need to find the left hand side, okay? We need to find the left hand side. We have A plus AB. Now to add AB to A, right? We need to find the value of AB, right? First we find the value of AB because we do not know the value of AB, right? We have the value of A, right? Now here we have the value of B. You can complete this table, okay? You can complete this table by yourself. Just take the multiplication of A and B. 0, 0, 0, 1. Am I correct? Now here we have the value of AB. Also we have the value of A. Now A is here, AB is here. We need to take the summation of these two columns. Okay, we take the summation of these two columns. 0 plus 0, 0. 0 plus 0, again 0. 1 plus 0, 1. 1 plus 1 plus 1, here we have 1. 1. Right? Now here you can see the values of A are 0, 0, 1, 1. And also we got values for A plus AB also equal to 0, 0, 1, 1. Okay. So you can see for the left hand side and right hand side, we got the same answers. We got the same values. So from this truth table, we can write left hand side is equal to right hand side. Okay. So we can see that our equation is true. Is that okay? That is the one method of perfect induction, okay? The idea of perfect induction is to show our equation is true for all possible combinations, okay? We need to identify the validity of the given equation, whether that's true or false. Then the perfect induction means we need to show the given equation is true for all possible input combinations, okay? So here we show that this equation is true for all possible input combinations, okay? So we showed that by using the truth table. That is only one method. So this is another method to show the validity of the Boolean expression, okay? Also, we need to show that the left-hand side is equal to the right-hand side by using, in this case, we are going to use the Boolean rules, okay? The rules we discussed earlier. I guess now you can remember the little bit among them, right? So we are going to use those rules to show the validity of this Boolean expression. We are going to show our left-hand side is equal to the right-hand side. To do that, we are going to, here we have the answer, okay? We'll start from the left-hand side, okay? Because of, in the other side, we have only A, we cannot simplify it, okay? So we'll start from left-hand side, right? We have A plus AB, right? Now how we simplify this one? We do the same thing, okay? The mathematical methods, if we have the summation, so to simplify this one, we find the common factors, okay? We can identify the common factors, the common values. If we take these two values, we have A, right? Can you see? A is common for both terms, okay? Here we have A, also here we have A. So we can take out A as the common factor. After taking A, what will happen? Here we have only one, right? Here we have only one. And the other case, after taking A from here, the remaining value is equal to B. Right? Now, how we simplify this one? Can you remember our rules? The result we discussed earlier, the result we got from that table, can you remember? We found this one, right? We found this one. If we add 1 to any variable, I hope you can remember, the final answer is equal to 1, right? We get the result is equal to 1. So you can see here instead of A, we have B, right? Whatever the value of A, after adding 1, the final answer becomes 1. So here you will get B plus 1 is equal to 1, right? So I got that answer by using previous rules. Okay, I guess you can remember, right? Here, can you see? And also here we proved that, okay? Here we got that answer. A plus 1 is equal to 1, right? So here to simplify these Boolean expressions, we use those results. That's why I told you you need to remember those rules to simplify the Boolean expressions, okay? Those are really important. If we add 1 to any variable, the answer is equal to 1. So you will get a times 1, and we know that if we multiply any variable by 1, the final answer is equal to A, right? We started from left-hand side and we show that, here we show that the left-hand side is equal to the right-hand side. So here you can see the validity of our Boolean expression, okay? Any doubts so far? To show the validity of any Boolean equation, Boolean expression, now we can use the, how many methods we have? We discussed only 2 methods, right? Remember that by using a truth table, we can show the validity of any equation, and also like this, by using the Boolean rules, we can show the validity of any Boolean expression, okay? Okay. Right. Now, I think that's enough for today, right? Now you have a homework. Here we had, right? Here we had 3 equations. You need to show the validity of these 3 equations, okay? We did one, right? We did first one, and there are 2 other equations. Also by using both methods, the truth table and also by using the Boolean rules, you need to show these 2 equations are true, right? You need to show that our left-hand side is equal to the right-hand side of these 2 equations, okay? Okay, any doubts so far? Any doubts? Okay, I think if you do not have any doubts, I think that's enough for today, right? So you need to complete this homework by yourself, right? I will check that next Friday, okay? So I will check that next Friday. You need to complete that. If you do not have any doubts, you can leave, okay? No, you do not need to upload homework. I will not grade this, okay? So let's check the answers on Friday, okay? Check the answers on Friday, so you do not need to upload this one, right? Do it by yourself and keep it with you. So we will check answers on Friday. Okay, and also I will upload this note to the Moodle. You can check that. Okay, if you do not have any doubts, you can leave. Have a nice day.